Hello, welcome to Snippet Bucket Technologies. Here is a pathfinder algorithms. There are several algorithms. Out of that one by one we're going to check how to reach from the first locations, means source locations to destination locations. Here the green indicate the starting point, red indicate the end point. Here the gray rectangle is a top border, or like we can enclosing borders, and in between we have blockage. I just obstacle that's here added. So this obstacle where we cannot move, and rest are the possible paths. So let's check with this A algorithm, asterisk algorithm. If we move with this one, there are uh, these are the possible visual efforts doing, and find the path by Manhattan. Now we changing algorithm bit. This is also taking more consumptions of the effort, so it's taking more efforts to find the right way. Here if we use the octile, in octile also is taking more visual effort compared to the Manhattan. Now we're going to use this one, chi by Shiva. This also here is consume more effort for processing to find the path. Now let's check this one, IDA algorithm. This is almost let me stop here. This one is hang almost my browser every time I use for complex search, IDA. So I just don't want to process this one because it's consume a lot of effort, where it's almost hang my browser. So let me first try to devisualize the recursive effort. Let's check processing, something processing. No, I don't want to go with this one. Okay, I just keep this idea is almost hang my browser. Seems like computations are highly used and it's not a furtive algorithm. Breadth breadth first search algorithm is consuming more effort, more and more effort to reach the target. Okay, but it's also give the good path. If I use don't cross the border, let's see. Yeah, that's also a good one, but it's taking more and more efforts to reach the destination. Let's say best search first. Best search first. If you see this visualization effort, this is processing is reduced. The competition is reduced the processing, and it's reached to the destinations. Okay, so here is the length is 74, and the 400 416 is the total operations consumed. Let's use this same but better version, this option, where you can see this one is much more less efforts to reach the destination. Then advanced version, octile, also the best and effective and fast one. Let's say don't cross the corners, so let's go and check. This is also the fast. This is also the most optimized one, chew by save, and let me say like allow diagonal. Okay, this is allow diagonal means straightforward diagonal allowed over here. If you can see this one, so if you're working with the artificial intelligence with the gaming and somewhere, then something helpful, very helpful. Don't cross corners and allow diagonal. So let's say path with allow diagonal. Okay, you can see this one, and also very less effortive. It's not scanning a lot of things over there. is using the less CPU powers or less competitions and doing the very fast one. Let's go with Daichakrata algorithm. Let's start scanning. A lot of competitions, a lot of things is processing. Okay, this might be helpful for somewhere in a visualizations or painting softwares, but not best in my considerations for the finding the path as exact. Visual efforts are more as more processing. Yeah, but it also gave a good path. Okay, now let's go with a different way. Bidirectional is something, both sides, like from source to destination, both side effort is uses, but that's something not required, because the always we want from the source to destinations toward one. So let's me go to the jump point search. I see that one a little bit faster, but let's see. Scanning a lot of things, you can see these gray areas. Okay, and then after this get the path. This is also good one. So is optimize path one, and here you can see the blue points. That's something they use the jump points algorithm. Let me check with the other options. This one is taking more processing. Okay, but if you can see that is something route is better here. The very important point is like, what is routes are a bit very important, because somewhere in a where you're working with the maps or robotics, and you are indoor navigation or something large scale navigations with limited zone, and then after what kind of path actually you needed or business needed, that's very important compared to this one. Let's say yeah, this is a different one, but let me go with this bridge. This one, you can see this one is going over here. So path is selected from here and is moving top, and then after is going on this blocks, where is something, there is also might be a bot, like robots are traveling that one. So it's good path or not good path, or path is something, that's on a based on your requirement need to be figured out. But if you see that one, this one is searching doing more effort, where that the previous one is doing less effort. But here if you can see this compared to that one, here the path is something straightforward from the outer side traveling, and then after is checking the diagonal straightforward, and then after reaching the destination. So it's not moving in a middle obstacle or something, middle robot somewhere if it is there traveling. So it depends what kind of path is best over here. Now next option, this is the same one. Now this one, tuba is saved. Okay, the same one, but is more effort over here is used. Then after the orthogonal jump point search, little bit I like this one, where most complicated search were bit much better I found personally, but I not suggest as personally to what you have to do. Is something what you have to do is depend on personal project and what kind of the navigations or pathfinding demands. Let's say search, consuming here the efforts. Okay, yeah. But effective path, you can see this one, effective path. This is going straight forward, and then after use the 48 length and 984 operations they do. But now let's see second operations, second options I'm using over here. Yeah, this is also the good one, where is something going straight forward from outside, and is going like for if I have a robot, is something good way is traveling. Okay, let me go with this other one. Searching, now it's doing a lot of effort over here, but let's say this is also the good path. Okay, so robot do not have a lot of curves. So if it's something robots or taking something a big high payload, then after is taking, if it is has a less curve, means it's something easy to travel for them. Let me go with second cheba here. You can see this little bit faster executions, but let's see, this is also the good one, same out effort over here. Now next one, trace algorithm. Let's say search. So you can see here is something doing more effort, like it's not great one, but somewhere it's effective, but sometimes it's not effective as well. So it's depend what kind of the path we required. Yeah, it's going over here, but like middle of the many obstacles they're traveling, and might be their other robots are playing around, so it's something might not great one, but it's faster one. You can see this one a little bit doing less effort to find the path. So it's based on requirement for paths, we can process accordingly. This is also the good one, straightforward. Then after is going here. Okay, so but an orthogonal, if you can see this one, is something somewhere optimize some path with as on requirement. Okay, so you have to figure out what kind of path we need. So these are the pathfinder with the different algorithms. Yes, this one is little bit where you can find is consider efforts because it's doing visual rendering, but actually without visual rendering, let's see that one is fast one. Okay, it's not taking too much time. Okay, it was very fast. So yeah, I just not use the visual guideline. Let's say I don't want to. Okay, let's search jump. Okay, let's say this is with search with visual recursion. Okay, but I don't use the visual recursion. Okay, then it's fast. Okay, so these are all the algorithms with the pathfinders from the source to destination locations. But here we do not getting the all the possible path, like it's moving from the top to bottom or somewhere. Okay, so here is something based on the algorithm is finding the right path. Thank you for watching. Thank you very much.